All right, today we're doing permutations. So permutations, you have to remember that they're going to be, a lot bigger than combinations if it's the same thing. Like let's say if it's 5C2, that's going to be a lot less than if it's 5P2, okay? And then over here we have the equation for it. So for you to follow, it's n factorial over n minus r factorial. And here, of course, order matters a lot. So let's go for the first one. So how many different password ID cards can be made if there are 7 digit spaces on a card and no digit can be repeated more than once? So we know that digits, we're talking about numbers here. So we know that there's 10, okay? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 10. So, and then we know that there's only 7 of those that will be like repeated. So we have 10p7, okay? That's going to be the the equation. So we're just I'm going to write this down here. 10 factorial and over 10 minus 7 factorial. That's going to be 10 times, 10 times 9, 8, 7, 6, 5, 4, 3, and I think I should have done the one in the bottom first because it would be 3 factorial. So we just cancel that out and we don't need a 2 or a 1. That just cancels out. So we just multiply these ones, and I'm just going to put that on the calculator. Just give me 1 sec. 10. And that should be 604,800. Okay, so there are 604,800 different ID card combinations that can be made if no digit could be repeated more than once. Okay, but now here it says, now what if they could be repeated more than once? Now that's actually very simple because what we do now is it's really just 10 to the power of 7 because those ones can be repeated. So the thing with permutations, and factorials rather, is that they decrease when you multiply each other. Like 10 factorial would be 10 times 9 times 8 times 7. If it's 10 to the 7th power, it's 10 times 10 to the 10, 7 times. Okay, and because of that, it's going to be, I don't know how many times, I just know it's 7 zeros. More, so that should be, it should be 10 million different ID card combinations that can be made if the digits can be repeated. So if you're ever asked this, repeating something is going to be much better for your security. Another way to look at this is like a visual explanation I'll give you is, 1, 2, 3, 4, 5, 6, 7. That's 7. That's the 7 digits, okay? And in each one of those, in this case, they can't be repeated. Okay, and there's 604,000, half a million different ways, and on this one there's 10 million ways if they can be repeated. That's just how to remember it. Here we have another problem. There are 12 shows, but there's only 5 openings during prime time. How many different ways can this order happen? So in this one, again, all of these order matters. It's a permutation video, but anyways, we know that this is a permutation because order matters because it's openings during prime time. So we have like 5 p.m., 6 p.m., 7 p.m., 8 p.m., 9 p.m., 10 p.m., etc. So here we're going to already know what it is. It's going to be 12p5, and then we know that it's n. That's going to be our equation just for reference. So it's going to be 12 over 12 minus 5 factorial. So let me do the bottom first. That should be 7 factorial. So we have 12 times 11 times 10 times 9 times 8 times 7 factorial. Cross that out. We just multiply that. And that should equal 95,040 different ways that this order can happen. So that's a lot of combinations. So now next one. You're playing Mario Kart and there are 12 total races. How many different ways can can first, second, and third occur? So it's the same thing. It's going to be, order matters because it's that's how it goes. So it's going to be 12p3, and let's write this here. Cross that 9 out, and then we have, that should be 11 times 10. That should be 121. And the total number should be 1,320 different ways we can have, the first, second, and third place occur within those 12 racers. So now we have this one over here. So a CEO has 7 different tasks to assign 1 to each of his 7 workers. How many different ways can he make the assignments? So he's not doing 7 for every 7 workers, otherwise that would be like 7 to the 7th power, I think. But this one is, what we do here is really, it's just 7p7. So what I'm going to do is, I'm going to actually go on the calculator, which I'll show you now. Let me see. So you go to math, which is underneath the alpha button, the green alpha button. Go to all the way to probability, and then go to 2, because that's where the NPR is. And, oh, I didn't even put the 7. Okay, so there we go. 7p7. That should be 5,040 different ways that he can make those assignments. So yeah, there it is. You might get confused by that and say, well, that's kind of weird, but you could think of it in a smaller number, like 3. You know, he's going to assign 3 tasks, 1 to each of his 3, workers. That would be like 3p3, and that would end up being like, I believe that would be like 6, I think. So that's how many different ways you can assign a task to those 3 people. Okay, so here, these 2 are not really, math, I guess, but they're still, problems that you might get. And here it says, is this permutation or combination? I'm just going to tell you right now, obviously these are permutations, but I'm going to explain to you why. So Jason looks at the shelf of his favorite Blu-ray movies and lists his favorite 5 ranked from first to 5th, right? He's gonna rank his favorite movies. So we know that this is a permutation because it's ranking something. He's putting it in order. Okay, if it was a combination, it would be more like, he has a shelf and he selects out of a shelf of 100, he selects 5 of his favorite. That would be a combination. That would be something like he's just choosing randomly. Here, this is a permutation because he's getting 5 and he's ranking them. Okay, and so there's more combinations for that than if he just selects, I guess, 5. And then over here, we have New Jersey elects a governor, lieutenant governor, and district attorney from a pool of 9 candidates. So over here, that would be like 9p5, but we're not really doing any math right now. I'm just explaining. So the reason why this is a permutation is because it's also order, it's ranked, and this is a hierarchical thing. Each one of those jobs is a different thing. The governor is like first, the lieutenant is like second, and then that would be like third, whatever. And so because of that, the order of it does matter, and you can't just have a random one be one of those. The order of it does matter a lot. And that could be 9, that could be 12, it doesn't matter. And it's still going to be a permutation. Okay, so here I'm going to show you how to do these problems in the calculator, because if you're in college you might have to use it. They might want you to show to work, but I showed you how to do it in the word problems anyways. So I'm just going to bring my TI-84 calculator over here. And over here we have 9 factorial over 9 minus 3 factorial. So we already know that's going to be, the larger number, the seed number is going to be the one in front of the p. Okay, and then the smaller one will be after. So we have 9p3, so I'm going to type here 9, okay? Go to math. Once again, it's below the alpha button, the green one. Then you got to go 2, and the factorial thing is also here, but in any case, we're going to go to 2 because that's what we want. And then we're going to type in the number that we want, which is 3. So that's going to give us 504. Okay, so now we go to the next one. We got 8, P2, so 8, math, away, probability, 2. Okay, we got 56 different ways for this one. For this one, we're going to go to 13, go to math, probability, go to 2, 7. Then we're going to get a large number. It's going to be something like in the billions or something. Let me just. We're going to get 8,600,000, whatever. Okay. So the next one we got 7p4, 7, math, probability 2, 4. Okay, we got 840 ways for that one. And this one, 10p6, 10, math, probability 2, 6. We got 151,200 ways. So that is how you do it in the calculator.